Okay, so welcome everyone. My name's Simon Smith. I'm a CFCI trustee and I'm hosting today's webinar, which is on Jesus College kitchens and Forum. So this is a bit about the design of the projects, but also some construction related information. So some nice photos of construction processes that we're going to see or where we are in construction. And today we're lucky to have a client, a contractor, a project manager and an engineer talking to us. So quite a wide range of information coming out of today. I'll introduce our speakers in a minute, but just to remind you all in the audience, we're going to host a Q&A session at the end of the talk today for 10 or 15 minutes, and I'll place your questions or pose your questions to our speakers. So if you could please raise any questions you have in either the Q&A tab or the chat tab, that will allow us to see your questions and pose them to our speakers. Okay, right, so why don't I do the introduction? So today, as I say, we're talking about Jesus College kitchens and Forum. We have Stuart Websdale, who's domestic bursar at Jesus College. He's going to give us a brief introduction to the projects that we're going to talk about. We've then got Dan Thomas from Northmores, who's going to cover a number of aspects, probably going to touch on a few things in terms of the project, but also its design, architectural design, I think. We've got Ciaran Begley from Gilbert, the contractors, who are on site at the moment with the works. And then we also have Mike Baldwin from Fordham's, who's going to talk about the college's exciting aspirations for zero carbon and how they're going to reduce their CO2 emissions. So why don't I stop talking and allow the team to start presenting. So I think we're going to hear first from Stuart. Stuart, over to you.
Thanks very much, Simon, and good afternoon, everybody. It's great to have you all joining us this afternoon. I'm not going to dazzle you with slides. I'm going to leave that to those that are following, particularly Dan, who's going to cover a range of things, including speaking on behalf of the architect, Paul Von Berg, who couldn't join us today. But what I thought I would do is just provide some context to why we're doing what we're doing and what were the drivers behind this project, which is quite complex. It's fairly disruptive in terms of day-to-day college life, and it's a fairly significant undertaking. So in terms of the drivers, the kitchen as it was pretty tired, pretty neglected, and not a particularly nice place to work. It was quite clearly the coldest kitchen I've ever walked into. So in terms of workspace and food production, dealing with increasing capacities, and for those on the call that appreciate hospitality operations, the changes and demands in terms of allergens is significantly shaping the way kitchens are being designed and are being used in the future. So so there's an element of operational efficiency, creating a really good place for people to work, because as we know, Cambridge is a really progressive city. It's growing, it's booming, and attracting and retaining staff is a really important aspect of day-to-day operation of any organisation, whether it be academic or something entirely commercial. So that was a really important aspect. I think creating a social space. People are working longer and harder, so it needs to be a nice place to work, but also a social space to work. And that includes front of house, so those that are in food service and those that are working in the kitchens as well. So, and for our community, for those that don't know Jesus, we've got a community of around about 1,200 people, which includes undergrads, postgrads, our academic and operational staff as well. So there's a real sense of community, and a lot of that revolves around hospitality and entertainment. Something that is really important to us is our environmental impact, and we see this as a really, really important step in our journey towards net zero. So the kitchen that we're creating will be completely free of fossil fuels. So Mike will go into that in considerable detail, but this is a fairly significant step with regards to the design from a mechanical, electrical perspective. So it not only needs to work well, but we're very mindful of the responsibilities we have with regards to climate and climate change. Architecture is an interesting one. We're surrounded by beautiful old buildings, but we see ourselves as custodians of a magnificent site, and so we see this is not only an opportunity to think short term, but we're laying the foundations, we think, for hundreds of years to come. So we have a real sense of responsibility that comes with this. So I think choosing the right team and the right design and engaging with the local authorities is really important so that we set the site up for centuries. So I think that's something that we take really quite seriously as custodians of the college. And then finally, sort of on a bit of a side note, the Fordham building, which Dan will go through, was an existing site. And it's a really good example where we think we've been incredibly resourceful in terms of space, but also thinking from an environmental perspective. Many of you will know there's always a college kitchen being upgraded in Cambridge. I think there's 3 or 4 on the go at the moment. We're incredibly fortunate in that we chose not to hire in kitchens. We had sufficient building space. We were able to create a complete kitchen as well as 2 dining spaces, which will very, very easily convert into meeting and events and conferencing space down the track. So the approach we've tried to bring to the whole project is to think very much long term with a strong focus on sustainability and creating a really nice space for our community to live and to work and to dine. And it's one that we're taking really quite seriously, but thoroughly enjoying. We've got a tremendous project team who are performing well. So I've set you guys up. So but thanks, but genuinely got a terrific team working hard, and I hope that you enjoy the presentation today. As we emerge from the pandemic, for those that want to visit site down the track when it's finished on time or even ahead of schedule, Ciaran, we'll see how we go. We're looking at the end of June, start of July next year. So for those that are interested in having a walk around, please do reach out in the future. We do think as a project people will be talking about for a little while to come. So that's the end of my introduction. I'll hand over to Dan Thomas from Northmores, who'll talk a bit about his role and his team and what they're doing, as well as most importantly how it's going to look. So yeah, Dan, over to you. Thank you.
Brilliant, thank you, Stuart. No pressure there with the on time and less than budget. I heard that absolutely loud and clear. I shall just share my screen. So as Stuart said, we're going to cover, trying to cover an awful lot here, covering elements of the architecture and generally how the project has reached the point it is today, before Ciaran will tell you exactly where it is today. So I'm going to aim to cover just a little talk through the Forum project, which was one of our biggest enabling works phases. Look at the site constraints and the origins of the brief around that. Looking at some of the design proposals and the complexities, this is a particularly challenging site, as will become clear, and resolving some of those issues is challenging. And then look at some visualizations and what our aspirations are for the project, before concluding with some of the challenges and lessons learned we've got, which hopefully will be of benefit to others embarking on similar journeys. As Stuart kindly mentioned, I think we've got an excellent team. There's been some key challenges on this project, not least of which, of course, COVID-19, and the cohesiveness of the team has been excellent. You'll see the key names here. I'm Dan Thomas from Northmores with the project managers, and you'll hear from Mike Baldwin, who are the mechanical, electrical and sustainability advisors from Max Fordham, and you'll hear from Ciaran at Gilbert Ash, representing his team there. Other ones of note on this is Paul Vonberg Architects. He's the longest serving member of this project team and has very much sat with the college for in excess of kind of 7-8 years now. And then people who have helped us get to this point through some financial difficulties and uncertainty, the likes of Faithful and Gould as our cost managers, life cycle costing and mechanical electrical cost advisors, and Price and Myers as our civils and structural engineers. So this is a delightful picture to start off with. I can assure you my pictures get slightly more attractive as we go on. The Forum, part of the original brief which was issued to the team in 2018 was to look at the temporary kitchen accommodation. Having delivered a number of kitchen projects, this typically takes the form of hired-in accommodation or marquees. But Jesus College is in a relatively unique position in terms of the grounds and buildings it has. So as the project team, we did a feasibility study of the existing estate and identified that there was the opportunity not only for temporary kitchen, but also for longer term investment in the Forum building. For those that aren't familiar with the Forum, it is heads out towards Park Street. It's adjacent to West Court, the new West Court development at Jesus College, and it was the site of the old Marshall's garages, so it has some historic relevance as well. As shown by these images here, it was very much used as overspill storage space, and I think it was used by the Mayball Committee, for example. What we were aiming to fit into this space was a complete replication of what the college had at the moment. So we had to replicate the kitchen area, the servery, hall, upper hall, without any compromises on the level of service or quality of what is provided. So we overlaid those requirements with what Stuart's ambitions were potentially as a longer term view on how the buildings could be utilised, what income streams there were, and what academic requirements there were for different spaces in the college. So I think I jumped on 2 slides there. No, I didn't. Effectively, we ended up meeting all of those objectives, and the project was completed over 1 term and a long vacation, ready for the start of Michaelmas term 2020. And we worked in partnership with Regent Construction Cambridge, who delivered the building work on a single stage design and build procurement route, working with the design team who we've previously outlined. This is a view of the replicated hall. We've tried to keep a modern feel to the building and making sure we introduce daylight, new views across the hockey pitches, keeping the same number of guests in hall. When we've done projects previously, there's too much emphasis on replicating the feel of the historic parts of the college. This very much gave us the opportunity to create a new identity for the space, both in the short term, but also for the conference and catering business opportunities going forward. Effectively, our biggest challenge we now face with this building, other than hopefully it will be opened up for conference and catering business when COVID restrictions allow, we've created a superb kitchen, and trying to now convince the college catering staff that we've got an even better kitchen a little bit further down the road and they want to move out is probably going to be our hardest challenge on this project, because they're thoroughly enjoying working and delivering service over in the Forum at the moment. So moving from the Forum, which has paved the way for us to do the larger kitchen refurbishment project, I've distilled the brief down as far as I possibly can into these 5 elements here. Circulation, as Stuart mentioned before, I mean, the distribution of food, accessibility for those with access impairments or disabilities, the route in for incoming goods, crossing over without going waste. It was confused, convoluted, and generally congested. The space available, the kitchens have pretty much remained the same size for just over 500 years. And at the point when they were first opened, they probably would have done about 30 meals a day. You're now talking about 300 meals in one sitting. And it is woefully undersized. They can't, to get the level of equipment and kit in there, not to mention that the number of staff is incredibly challenging. Linked to that is the environment and well-being. I mean, that kitchen suffers from extremes of temperature. It was freezing cold, boiling hot, drafty, with huge congestion from the number of people moving around, and needed to be addressed very, very urgently. And then sustainability and longevity. I'm not going to touch too much on sustainability. There's a huge amount of that in Mike's presentation in a little while. And longevity, as Stuart said, this is a college project. We all recognise that the view is that this will provide a long-term installation to meet the requirements of the college for years to come. And we needed to consider not only the current requirements, but possible changes in service requirements, teaching requirements, and particularly now energy provision and availability. So for those of you that don't know the site, as I think when we first showed this to Gilbert Ash, there was a wince when they saw this site area. The site area is showed in red on this plan. That's Pump Court. And this is effectively the site area. And the area to the south of the site, if I just get my laser pointer up, the area to the south of the site here is the hall. The site's at the heart of the college. It's pretty much enclosed by buildings on all sides. There is a small gap through here over this side towards North Court, and the buildings all around the periphery of the site are Grade 1 listed and originate back to the original Benedictine nunnery, which was located on the site in the 1100s. So it's got its challenges, not least of which from accessibility and historic fabric. Given those challenges, there's not really an opportunity to expand without relocating the kitchens elsewhere. And that was something that the college were keen to see, that the kitchens remained at the heart of the site. And therefore we explored the most viable opportunity, which was to expand downwards. I've started with this section because the existing kitchens in this location are having their floors lowered. There's an expansion to the side, which constitutes this extension at ground floor and lower ground floor level. And then there is a large basement area, which includes back of house service, storage, wine cellars, plant room in the basement area beneath. It's probably slightly easier to see from the axonometric view here. From very early stages, we took the decision to completely 3D model not only the new elements of the structure, but the existing college as well. So cloud surveys were taken, point cloud surveys were taken of the building, and that's proved an invaluable tool, particularly from services coordination perspective. The lighter grey areas on this plan show the new interventions. So we've got the new, I'm always banned from calling it a lean-to extension. If Paul Vunberg was on this call, he would be glaring at me now, but the new extension to the side of hall. We have a new 3-storey extension here, which is going to improve circulation into upper hall and the servery areas. And then you can see here the sizable footprint of the basement area with the plant room area and the wine storage area and the ancillary spaces beneath, and how this then ties through with the new screens passage here into the existing hall. One of our key challenges has been the treatment of one of the only visible elements of the building, which is the single-storey extension, and the way that that ties into the historic fabric of the hall. In planning terms, this has been a challenge, and we've been through several iterations with the local authority to make sure that the facade treatment was handled respectfully and with consideration to its surroundings. We've worked closely with the conservation officer and the college archivist to achieve that. One example is the diaper brickwork, which is seen here, is prominent on a number of significant elevations elsewhere within the college. And finally, in terms of plans and what the proposals were, is the landscaping. So on this plan, the basement area, which we talked about previously, sits where my laser pointer is going at the moment, in this kind of area. We've introduced reintroduced, should I say, the green area of Pump Court, which is obviously a key feature, having a green court in the college. But the college have opted to include more of a hard landscaped area. And that's for a number of reasons, but it particularly provides outdoor space for outdoor functions, meeting, circulation space. And I'll talk a little bit more detail about some of the features there when we look at some of the visualizations. This is the existing view from Pump Court, standing looking back towards the hall. You can see nice green Pump Court. And from here, as if by magic, you can see our minimal interventions. I think the key thing to note on this this section is that most of the work is invisible, and that is incredibly intentional. There is a huge overhaul in kitchen facilities, kitchen function, and massive benefits operationally, but with very little change to what you can see in Pump Court, and therefore a real preservation of the historic views and historic feel of this part of the college. So we can see the single-storey extension here, and we can just see the smaller scale 3-storey extension over here. That looks in just a little bit closer, and you can see the new steps which will form an entrance into Screens Passage, which have been closed off for some time, but reintroduces this historic feature, which is at the heart of the college catering function. Again, this is an existing view looking back across to the site of the 3-storey extension, which magically appears. The 3-storey extension here, the two things to kind of pick out on this one, you'll see some slightly quirky, odd things where my laser pointer is now. These are very carefully selected with the college archivist and Paul Vunberg and our archaeologist items which have either been removed from the archaeological excavations on site or from the college's stone store, to reintroduce elements of historic features from the nunnery and the previous Waterhouse buildings which stood on this site into the new building, to give it a degree of a nod back to the college's heritage. And the other is this slightly interesting paving that exists. These circular sections of pavers here at the front have multiple purposes. One, they're quite aesthetic and obviously are mirrored by these planters here. The other is that they have a number of them have light wells in, which allow light into some of the more regularly frequented parts of the basement. And the ones which are discs like this are a vital part of the smoke ventilation strategy for the basement. And this is just an internal view. We haven't got many internal visualizations, but this just gives you a view of the servery area. This is a particular favourite of the contractor, who very early on spotted that it will be very dark in this space, as I think there's no lights actually shown on this visualization, but I can assure you that it will be lit, Mr. Client. The key element here is looking at the well-being comment we made with the brief before, and the way that we've reintroduced natural light into the space, and the choice of finishes will make this a much more pleasant place for the operators to work. So looking at some of the key challenges, I've picked 3 out here. I've deliberately not mentioned COVID. I think everybody will have experienced some challenges through COVID. In relation to this project, we delayed commencement on site, and we adjusted to a phased approach, which allowed better planning and use of the space for social distancing measures during the early stage of the pandemic. And I think that it was a collaborative decision taken by the college and the team, which has been successful. But one of these challenges in this rather busy slide, you'll be pleased to know that Mike has a much more zoomed in and one with better explanation later, is to talk about the ground source heat pump installation. So our site that we were talking about a moment ago is in this location here. Our ground source heat pump array is here, and the very immaculately manicured cricket square is here. Effectively, the location of this has benefits, as Michael will talk through. The ground source heat pump array provides 100% of the heating and cooling for the new building, and has the ability to be expanded in the future. But as you can imagine, with that location at the centre of a college, there were many issues which needed careful management relating to the timing of the works, the securing of the RHI, again, which Michael will talk about, archaeology on an area of the college which has been largely undisturbed, and also the wider impact generally of works on college life, not least of which the cricket season. And the next challenge I've highlighted here is the historic fabric. We've mentioned it's grade 1 listed, but as with all of grade 1 listed buildings, there are features within grade 1 listed buildings which are even more remarkable and need additional protection. The image here I've chosen is of Upper Hall, and there's some artwork, as you can see here on this wall. This is an installation by Richard Long, applied directly to the historic fabric of Upper Hall. And we've also opted, as part of the design, to route the main ventilation ductwork immediately behind this artwork, which cannot be moved and needs to be protected. And as such, we've had to work very carefully with the college's Works of Arts Committee and with the contractor to make sure we have maintained the right climate conditions for protecting that piece of artwork. Within the basement area, there's been a number of unforeseen features, should we say, that have arisen. Again, Ciaran will talk about some of these in more detail, but in summary, they largely covered more recent interventions, which tend to be of very robust and reinforced concrete, albeit in slightly unusual configurations. Previous evidence of underpinning with no record of it ever being undertaken, and rather unusual structural supports for parts of historic floors, which have had to be attended to. In essence, the team have had to work incredibly hard to keep the flow of information up and be flexible against what was an incredibly detailed and well advanced RIBA work stage 4 design, to make sure that the main contractor can protect the programme on site. And it wouldn't be a city centre college project without talking about archaeology, which is has given us all some head scratching on this one. I think this is referred to as Sod's Law, but having worked for 2 years to carry out myriad investigation, research and interrogation of that site, including some quite large trial pits, trial trenches, we managed to miss everything of significance, which subsequently we then uncovered when we started the excavation works. We wanted to do excavation works before the construction. Unfortunately, due to a prolongation to the planning process and approvals process, we didn't have our consent in time enough to allow us to do the level of archaeological works we wanted to do. And as such, an extensive phase of archaeological works commenced in Pump Court, inside the building, in the area of the basement and in the area of the ground source heat pumps, in parallel with the works being commenced by Gilbert Ash. The archaeologist, Cotswold Archaeology, working in partnership with Cambridge Archaeological Research, made significant discoveries on site. You can find out further information about their discoveries they made on the Cotswold Archaeology website. But as you can imagine, Stuart was particularly concerned when they described their discoveries as extraordinary, which is always a slightly concerning one. And needless to say, they found some quite interesting artifacts down there, and the programme realistically and rightly had to be extended by just over 2 months for the archaeological works. This is really testament to the way the team's behaved and the fact that we've been relatively free thinking about how we can sequence. We took some early decisions, we've resequenced, we've replanned, we've rescoped, and what that's meant is that 2.5 months has had absolutely no impact on the end date of the project, and we still remain on track for handing over in 2022. So that concludes my whistle-stop tour of many different parts of the college there. I shall stop sharing and I shall hand over to Ciaran, who can tell you about how difficult we've made his life as project managers and clients now.
Okay. Okay, good afternoon, everyone. So yes, I'm Ciaran Begley, Project Director for Gilbert Ash. I'm just going to give a bit of an overview on where we're at with the construction process, what we've done over the last few months, a couple of the things that we found on site, and where we hope to be in the next few months. So the first slide there is, as Dan touched on, archaeology. A big part of this project to date has focused around the archaeology. Obviously, they've found some quite interesting things, and really the whole program, etc., has been dictated by that to date. Oh. Next slide. Okay, so the construction for us, we've basically split it down into 4 parts. So there's a new single-story basement, which is a secant piled wall, RC frame, cavity drainage, and approximately 2.5 meters cubed of excavation. I'm labelling that as the easy bit. There's not that much easy about it, but the fact that it's all new work, sort of stability of the design, it is what it is, and we know what we have to build and we can get on with it. There's also then a new single-story extension, which is a steel frame founded off the new basement structure, with its clad in stone and brick, with a lead roof and thermally broken connections to the existing structure. Then there's a 3-story extension, again steel frame, connected into the existing structure. Some fairly significant interventions in with the openings through the existing facade, obviously to connect into each of the new floor spaces. And then probably the hardest part is the complete strip out and refurbishment of the existing kitchen areas, which also involves new lowered floor slabs. We're about 1,400 mil below the existing floors, and that requires significant underpinning of the existing foundations. Quick overview of programme. It seems like a long time ago. We started in September 2020. We actually tendered this project in March 2020. The world was in a very strange place then, as we can all remember. And we were delighted that the client and many other clients at that time had the confidence to proceed with their projects. And we're all reaping the benefits of that now with a very buoyant sector. CFA piling for the new basement, we started in October, got that wrapped up just before Christmas. The plan was to get, because of the proximity of the new basement to the existing building, the plan was to get the CFA piling in first, and then the archaeology progressed after that, so that the archaeological dig wasn't compromising any of the existing foundations. So that they got started just before Christmas. They've worked extremely hard through the harshest of weather conditions, and they've pretty much finished up in April. We're now in the middle of a 9-week non-working period due to the exams. Quite rightly, the college, I guess, didn't trust us to work quietly, given the fact that students are doing a lot of their exams, etc., from their rooms, and they've had a hard year. Being on site recently, it is eerily quiet, so I can understand sometimes on a construction site you think you're not making noise, but really you are. The main build then, so when we get back to site, we're due back on the 28th of June, so effectively from July 21 to February 22 is the main build. Fit out following on after that with PC expected in July 22. And a big part of the works, which are also starting now in June, is the ground source heat pump, which I know Mike's going to talk about. But one of the big program challenges is for us to have the new basement, which houses the plant room, built and have the kit in there and commissioned so that the client can obviously avail of the RHI scheme. So effectively, we need a commissioning system in some shape or form for the ground source heat pump by the end of March 22. Current position, seeking pilings completed, archaeology completed. We then returned after the archaeological works to complete the central load-bearing piles. And we've also installed some temporary piles, which is to do with the top-down construction, which I'll touch on later. The internal strip-out works is completed, and really that has given us an opportunity to properly review the existing structure and the various challenges and conditions associated with that. Easy for us to go in there and strip it out, a lot more difficult for the structural engineer to go in and interpret what is there. And basically we've left the site. When we left there in the middle of May, we've now left it ready for the top-down basement construction and the various structural interventions of the existing facades. And like I touched on, we're in the middle now of the 9-week non-working period. Biggest challenge probably on this job, and it is what it is, we knew before we signed up to it, and it's the first conversation we have with every subcontractor who gets involved in the project, is the restricted site access. So absolutely everything we have to do comes in and out through that archway. It's about 2.8 meters wide, 22.50 high. That affects all of our decisions regarding plant, excavators, piling rigs, new equipment that's coming in, ground source heat pumps, big waste separator tank, 700 grand's worth of catering equipment, etc. Everything comes in and out through that archway. So that's us. The arrow shows us coming in through the college grounds. We have a set down area, materials come in through the arch, and the yellow circle there is the very restricted pump court site. Just a quick overview of our site setup, which thankfully the client has allowed us to expand on that, which gives us more room for welfare facilities, particularly in response to COVID. One of the main challenges then was with getting our piling rig in. This is by no means a mini rig, but it is a very small rig, and ultimately that had a big bearing on the program. Those rigs, they have to auger basically in 1.2 meter sections. These were also temporary cased, so effectively that had a significant impact on the program for piling. The productivity that we achieved, so we had 204 temporary case seeking piles, 600 diameter, 14 meters deep. We started on the 16th of October and we finished on the 4th of December. Had that been a more accessible site with a bigger rig, we probably would have went round that in 2 or 3 weeks. And basically the piling, it was a temporary case seeking pile. So we cased down through the made ground, through the gravels, got a toe into the clay, and then after we cast the pile, we obviously took the cases back out immediately. And all of the muck away and all of the arisings is done using a conveyor. Archaeology is done, touched on. So basically we've been attending to the archaeologists over the last 3 or 4 months. I don't think there was 1 square meter of the site where they didn't find anything of historical significance. It was actually a shame. It came to a point in the project where the archaeologists had done all their work. And of course, we then moved in there with the excavators and we broke up all of that material and put it through the crusher. and that has now been levelled out as our formation layer for our lower ground floor slab. The existing building has thrown up some challenges, again, most significantly for the structural engineer. And I guess because the existing kitchen was in full operational use up to a point until the new Fordham project was ready, it made it very, very difficult for us and the design team to get in there early to carry out opening up works. Obviously, it's a hygienic environment, and it's not easy to get in to open up ceilings or floors or whatever. And the result of that, as soon as we get in to carry out the demolition works, we've obviously had, in some cases, daily meetings on site with the structural engineer and the architect, looking at some of the surprises that this has thrown up. Biggest one to date has been with the underpinning. In recent years, probably 20, 30 years ago, there's been some level of refurbishment carried out on the building where they must have lowered the floors and they subsequently underpinned the foundation. But unfortunately, they only underpinned halfway across the wall. The impact for us, so this is what they found. So that big lump of really hard concrete that you see there is the previous underpinning that's been carried out. And what that meant is that we've now had to carry out the underpinning in 2 phases. So that's an image there of our trench sheeting. That particular one is ready to pour. That's the existing condition that we found. So you can see the existing pin only partly supporting the existing load-bearing wall. And then to the other side of that is the original foundation. It's labelled there as sand. It's more like a chalk, like thin layers of chalk that was holding up the existing wall. So what we've had to do is underpin section 1 as planned from inside the building, not particularly disruptive for the client. It's the way we always intended to do it. But unfortunately, then there's this second square, which we'll have to come at from the second side, which means we'll have to go out into first court, which is a little bit more disruptive, and then finish off the underpin. We had contemplated breaking out the existing concrete, but due to the potential, the vibration and the impact on the historic structure, and the fact that the new concrete that we put in definitely wouldn't be any better or harder or stronger than the concrete that was already there. So the decision was to leave that existing underpinning in. But it was quite an interesting challenge that none of us have foreseen. Floor structures is another one. So again, once the dining hall floor, once we had all of the strip out done, the dining hall floor is currently being supported by several load-bearing walls, which we have subsequently demolished. And the plan is to put new supporting steel in to support those floors. But some of the conditions we encountered, so there's the existing dining hall floor, which one would expect would be a relatively common joisted floor with finished timber flooring on top. What we actually found was this condition. And when I think back to our site manager one Friday afternoon on Microsoft Teams trying to explain this to the rest of the team, it was one of the funniest Teams calls I had all year. But thankfully, we had a structural engineer on hand who could sketch it up within 5 minutes. But what we actually found was the existing floor was effectively like a York stone paving slab that sat directly on top of timber planks on the original beams. But then subsequently on top of that, there is a new joisted floor on battens with the finished floor. So that is subsequently a much heavier structure. And it resulted in the need then for a complete redesign of the new structural steel to support the floor. That's an indication of the existing historic beams that we found. Considering they're 300 years old, they're actually in very good condition. We've had Preserva in who carried out a survey on them. A little bit of wet rot at the end of some of the beams, a little bit of beetle infestation. So we've taken all the paint off those, and Preserva are coming in now in a couple of weeks to treat them, and hopefully they will last for another 300 years. The next phase, so when we come back on the 28th, we are going to start the top-down construction, and given that it's a single-story basement, it's a fair question to ask, well, why go with the top-down? So feeding into our thinking here, no matter how fast we go in this basement with the excavation, we are dependent on a conveyor system to get the muck away, and that's going to be very, very slow. Also, given the complexity of the logistics around the site, it would be very difficult to bring in what would probably be a 500-ton crane to lift temporary props into the new basement area. So effectively what we've decided to do is put the lower ground floor slab in first to prop the secant pile wall in the temporary condition, and then we excavate out below it and build the basement in below it. The advantages of that are that it means that we can get going with the single story and the 3-story extensions quicker. But most importantly, it also means that we will get the waterproofing over the basement done much quicker, which in turn gets the mechanical plant room ready earlier. And that should assist us with getting the ground source heat pumps in and commissioned by March 22. That's an image of our site as we left it. So that is sitting at formation layer for the lower ground floor slab. So that slab will get dialed into the side of the secant pile wall. And we've installed 17 temporary piles in the center, which effectively act as columns that will hold the lower ground floor slab up. And whilst we really loved having the archaeologists on site and seeing all of their good work, we're also relishing getting back in June and really getting stuck into this project properly and making some good progress. So that's my section. So I'll hand you over now to Michael, who's going to give an overview of the mechanical and electrical services and the sustainability.
Thanks, Ciaran. I'll share my screen. I'll try and do that again.
Mike, we saw the PowerPoint just then as you closed the down. So if you can get back to where you were.
Yep, just trying, Simon.
Yep. I'll let you know when we see it again. Whilst Mike's doing that, if I can ask some of our attendees if they have any questions for our speakers to raise them in the chat box. Okay, Mike, so we can see your PowerPoint, but that's it. Here we go. Yes, super. You're on. Okay.
Fantastic.
Thanks, Mike.
No problem. Good afternoon, everybody. Thanks, Ciaran. I'm going to try to dance you through sustainability and heat pumping in approximately 10 minutes or less. There were 1 or 2 slides I might have to miss out just due to the time constraints, but here goes. So I'm Michael Baldwin, Senior Partner at Max Fordham's Cambridge office, and we're celebrating our 20th year in Cambridge this year. Credit where credit's due. The bulk of the work for the project on site is being carried out by our senior engineer and team leader, Aaron Southwood, who's liaising with Ciaran and his team. We're appointed to provide MEP design services and sustainability from our sustainability team and post-occupancy evaluation when the job's finished. We're appointed directly to Jesus College throughout stages 1 to 6. On a non-standard form of appointment, and we're working with our colleagues at Munro Building Services and GCOR, the specialist subcontractor for the borehole installation. So firstly, sustainability. The sustainability drivers for the project in no particular order. First of all, compliance with planning is a sort of obvious one, but then moving on, minimising energy and carbon emissions, transition to net zero carbon, as mentioned by a couple of the speakers today. Wasn't explicitly part of the 2017 brief, but it's underpinned everything that we've done on the project thus far. Responsibility in terms of Jesus College, educating users and influencing long-term behavioural change, and also responsible procurement, both in terms of this construction project, but the operation of the kitchen as well. And also staff wellbeing and satisfaction, and Jesus College's reputation as a place of leadership in sustainability and decarbonisation. So we carried out early sustainability workshop with the college and we identified 3 significant impacts. 1, embodied carbon of the building, particularly the new basement construction. Secondly, operational energy consumption of the building itself and the catering operation, and embodied carbon impact of the food production process in the kitchens. And it's the second of those things that I'll be largely concerned with in this presentation today. In terms of planning, for an existing building of this nature and an energy-intensive function, such as catering, something like a BREEAM assessment isn't really appropriate. So we carried out early engagement with the city planners, and they agreed that some form of bespoke assessment methodology to assess the impact of environmental performance of the proposals would be supported, which was music to our ears, because we were able to introduce the college to our Max Fordham bespoke sustainability matrix. For those of you that don't know what that is, it's a sort of a mature form of sustainability assessment and target setting tool that's been evolving over the last 10 years, and crucially, it's known and trusted by the City Council planners. We used that at an early stage in the project to set sustainability targets across a range of criteria that I'll show you in a second. And we made sure that those criteria are met by writing those criteria into the contract sustainability prelims and cross-referencing them from within the MEP specifications. And ensuring that we're adhering to and sticking to the targets is done throughout the process by carrying out checkpoint sustainability reviews at each REBA stage. I don't expect you to be able to read the text on the matrix here, but this is just to illustrate the range of the different criteria that are assessed by the matrix and that we've set targets against. Things like energy targets for hot water heating, renewable energy, artificial lighting, catering equipment performance, passive design aspects such as U-values, natural ventilation, daylight, climate change adaptation, and then moving on, ecology, water consumption, construction materials, on-site waste and management, health and well-being, and then very crucially for a kitchen, the food production process. They're assessed and targets set against either minimum standards, best practice, innovative, or engineering. So touching on just some of the innovative aspects of this project, we've got 100% of the heat and cooling provided by electric heat pumps, no natural gas at all. Heat pumps used for cooling room and refrigeration room cooling. Waste heat from cooling systems recovered and used in the heating systems. High temperature second stage heat pumping used for domestic hot water production. We've got energy efficient artificial lighting design with up to and no more than 1 watt per 100 lux of lighting output. We've inputted to the selection of the very most efficient, energy efficient commercial catering equipment, and something that's been touched on by others on the presentation, daylighting, provision of roof lights and daylighting to kitchen and servery working areas, which massively improves staff well-being for the people who've got to work in traditionally dingy kitchens. Many of you will be familiar with this graph or other versions of it. It shows carbon emission factors in kilograms CO2 per kilowatt hour for the national grid in blue, and how that's projected to decarbonise over the next 30 years up towards 2050, or in fact 2049 as it says on this slide. This demonstrates very clearly why any sustainable energy strategy must include the transition to electricity as a fuel source. The vertical drop-down lines show points in time, but basically what it shows is that from the point in time now, within 10 years, the electricity grid is forecast to decarbonise by 50%, and then within the next 10 years after that, i.e. in a 20-year time frame, a further 50% down to 25% of its current value. It means that the switch to electricity is and has to be a fundamental requirement of moving to a net zero carbon operational energy future. So specifics for the ground source heat pump system at the college. So why did we select ground source? Well, invisibility and heat pumps silent in operation within a site-wide context, and by that we mean the heat exchange is done below ground, so it's invisible. The heat pumps are located in a new basement plant room where the noise can be controlled. Ground source offers higher achievable seasonal coefficient performance due mainly to its stable source temperatures. For this particular project, ground source was able to achieve higher RHI payment than an equivalent air source system, and then heat pumps are easily configured to provide simultaneous heating and cooling and avoid the need for external heat exchange and heat rejection plant. There's a simple schematic, which again, I don't expect you to be able to see the text on, but the numbers for the people that want to see them. In terms of peak heating capacity from the ground source heat pump system, 360 kilowatts, peak cooling 45 kilowatts peak. The heating for space heating, 600,000 kilowatt hours per annum, and for domestic hot water production, 70,000 kilowatts per annum. We've got 2-stage heat pumping going on. First stage takes the external water from the boreholes and raises it to 45 degrees C, where it can be used in new underfloor heating and new low temperature wall emitters. We're also taking chilled water from the first stage heat pumping at a flow temperature of 6 degrees and a return of 12. But also the output from that first stage can be fed into a second stage, which crucially can raise the temperature to 80 degrees so that it can coordinate with existing heat emitters in the existing parts of the college that we're refeeding, and also can provide domestic hot water production for the new kitchens. So location options. Numerous options were looked at. Here are 4 of them. There's the area to the west of the cricket square, 360 kilowatt peak potential yield. Area to the east of the cricket square, 480 kilowatts, with potentially other areas such as the football pitch, 550 kilowatts, and an area to the north of West Court, 210 kilowatts, giving just those 4 areas showing a total potential for 1.6 megawatts of heat through ground source heat exchange. It's worth saying that the Jesus College are no strangers to ground source. They have successfully been operating a modest ground source system for a number of years, located in the rectangle shown in pink there. And it's also worth saying that, as you can clearly see, Jesus College are fortunate that they've got a relatively generous land area, which isn't always the case in a city centre site. So there are other areas that could be looked at in the future if 1.6 weren't to be enough in terms of an overall strategy. So the final location, as we've seen on one of Dan's slide, but in a bit more detail, we've got 48 boreholes, 155 metres deep for each borehole. They're set out at minimum 8-metre centres. The flow and return pipework is collected in manifold chambers and then runs into pump court and into the new basement plant room. So following archaeological investigation, Ciaran and his team should be able to make a start on installing the boreholes in approximately July of this year. And the main bulk of the disruption should hopefully be limited to 3 to 4 weeks whilst the boreholes are formed themselves. And then lastly, but by no means leastly, a word about renewable heat incentive. The project programmes are fortunate in that it's been able to correspond with availability of RHI from the government. So Jesus College have locked in tariff awards of Tier 1, 7 pence per kilowatt hour approximately, and Tier 2, 2 pence per kilowatt hour. And it's expected that 90% of the heat generated from the heat pumps will attract RHI at Tier 1, which is great. The tariff guarantee is for 20 years. And as Ciaran's pointed out, the target is that we need to have the ground source heat pump system operationally commissioned by 1st of April 2022 in order to lock those tariffs in. On a simple payback basis, if people are interested, that gives for the overall cost of the heat pump installation an overall simple payback of 19 years and 9 months. And just in red there, the point is that if we don't meet the 1st of April 2022, we will still be able to get RHI, but just at a lower rate. And on a wider sense for new applications in terms of new projects. Sadly, commercial RHI closed on the 31st of March 2021, so no longer available in its current form, although I know the government are looking at potential alternatives. So that's my whistle-stop tour dancing through, and we just pose a question at the very end here, and correct me if anybody from the audience knows otherwise, but we believe, due to the aspirations of Jesus College, that this is the first Cambridge College kitchen where 100% of the heating and cooling demand is supplied from renewable energy sources. Thank you very much.
Super, thank you, Mike. Sorry to rush you there. That felt very rushed, but I appreciate you getting us a little bit back on track. So. Yeah. So thanks, Mike. Yeah, some fascinating numbers there at the end, Mike, of renewables and energy, and I loved that graph with the very much a picture-oriented person, but the graph showing the red line of the gas and the electricity dipping below that line. You know, yep. Now you know it's really sends that home as to why we're moving to electric and why we're being told by the government that new boilers are going to be, gas boilers are going to be banned in new buildings going forward. Anyway, so yes, some other points of note. Ciaran, I thought your talk was extremely helpful for the construction methods that you have to employ in some of these very congested sites, you know, around Cambridge, and there's a number of them that we have. So I'm sure many of our CFCI members there have got some useful tips from you, Ciaran, on how to build in congested sites. I'm minded to ask, in the time that we've got, probably just one question actually, and I guess that could be answered probably a bit by Dan, but also primarily by Stuart, and that is in terms of the ground source heat pump and the RHIs, and Mike's last point there about the those commercial RHIs now no longer being available. What do we think in terms of colleges' appetite, and in fact, and developers' appetite to invest in renewable technologies if the funding is no longer there? What's the appetite? My feeling is that we just have to do it anyway, but commercially,
I think that's right, Simon. I think we had a long dilemma. The RHI process for an installation this sizable and with the timescales we were dealing with, certainly with uncertainty around COVID, meant that we were faced with the prospect of the RHI not being available. And it really, for me, was very clear that the college, their aspirations wouldn't change. The RFI was an added bonus while it was there, and it was going to help the development and help push the development forward, and it's helped accelerate things. But it was made very clear to me that irrespective of whether that was available or not, the college are wedded, quite rightly, to the net zero carbon ambitions and the targets they've set, and that ground source heat pump would have gone back in there, and we just wouldn't have had a slide on payback period. So I think it's, it's less about this being a source of revenue or an income stream. This is more about us morally undertaking our duty and recommending to clients and supporting clients to do the same.
Super. Yeah. Thank you. Okay. Well, look, I'm afraid, speakers, we are running out of time. I mean, I was going to ask Ciaran how he's going to get all of his staff back when the exam period's over again, or have they all gone on holiday? But those construction lulls are actually probably quite helpful in some respects, as you mentioned, with some of the opening up works. But look, to our full list of speakers today, to Stuart, to Dan, to Ciaran and Mike, thank you very much for a very informative presentation. And I think for our CFCI members, sort of seeing these sort of part design, part construction presentations is very useful for us to all learn from, especially some of the archaeology finds that you had on the project. And your initial slide where you showed the full design team, I think that just reminds us what a team effort this is. And I should be reminded to make sure that I also thank in our last presentation for Croft Gardens, we didn't have a full team slide, and I should thank the QS and PM Faithful and Gould, and RMA Landscape and Max Fordham M&E on the previous presentation we had on Croft Gardens, which we forgot to do at the time. My mistake, or my bad, as my children say. So listen, thank you very much again, Stuart, Dan, Ciaran and Mike. It's been, I think only our CFCI members really appreciate you spending your time and your lunch break doing this. And we wish you all the success when you restart in July. Good. Okay. Thank you very much, everybody. Keep an eye on your emails for the next CFCI webinar. I'm sure we're going to have one within the next month. So can't tell you what it is yet, but negotiations are already underway. Have a good rest of the day, everybody. Goodbye.